Okay, once again, good afternoon, everybody. Assalamu alaikum and Bismillah ar-Rahman ar-Rahim. Again, very welcome to this prestigious conference of medical sciences, theming neonatology and fetal medicine. We will start in a minute, and I think if the people can come and settle down, please take your chairs. And kindly, if you put your mobiles on silent, so it will not disrupt the other participant and the speakers, of course. So without further ado, it's my pleasure and honor to introduce another winner of this Sheikh Hamdan Award and another prestigious and eminent speaker, Professor Nicholas Wald, who is working in Wolfson Institute of Preventive Medicine. He's a professor of environmental and preventive medicine in the London University. Is well known for his research work in epidemiology and preventive medicine. He has pioneered in the field of antenatal screening in early pregnancy for congenital malformation based on biochemical maternal serum markers, starting with alpha-fetoprotein measurements in maternal serum as a marker for spina bifida, which now form the basis of a screen for neural tube defects and Down syndromes also. He later developed further serum screening tests for the diagnosis of trisomies and revolutionizing the prenatal diagnosis. He has extensive work in that area, in that field, and today he is going to enlighten us on folic acid and neural tube defects, a journey of discovery and the challenge of prevention. I welcome Professor Wald to give us a nice talk. Thank you very much.
Good afternoon, ladies and gentlemen. I'd like to start by thanking His Highness Sheikh Hamdan bin Rashid Al Maktoum, the Board of Trustees, and all the members of the Scientific Committee for inviting me here to this meeting and for awarding me the prize that I received yesterday. I very much appreciate it and most thankful to all of you. The initiative that has been taken in respect of the prizes and the meeting, I think is a really quite significant step. The generosity that's arisen from the award and the publications and the meeting is, I think, extremely important, and promoting advances in medicine and the delivery of health care. I do personally think, and I'd like to say this as a credit to the host, that it's an outstanding Arab initiative in the promotion of health and science, but particularly since it's for the benefit of all people throughout the world. Neural tube defects are a global problem. The worldwide estimate is that there are about 300,000 infants born every year with a neural tube defect. In 1991, collaborative work was published in The Lancet that showed clearly that taking folic acid immediately before pregnancy, not after pregnancy, had a significant effect in reducing the risk of neural tube defects. Now, this work was published in July 1991. It's not far off, 20, 25 years ago. Our 1,817 women who'd had a neural tube defect were recruited into the study, and the results of the study were based on 1,195 completed pregnancies. The work came from 33 medical centers in 7 countries. This shows the countries: Canada, Hungary, UK, France, USSR, Israel, and Australia. It was a randomized, double-blind controlled trial, and there were 4 treatment groups. In fact, we employed what's known as a factorial design. One group, let's call it A, were offered folic acid, 4 milligrams a day. Second group had the folic acid and other vitamins, which are specified here at the bottom. Third group had no vitamins, so you could call that the placebo, and the other group had the other vitamins. So really we could answer 2 questions at the same time. The first is a comparison of neural tube defect rates in groups A and B combined, these 2 combined, compared to those, estimates the effect of folic acid in the prevention of neural tube defects. The comparison of B and D combined versus A and C combined estimates the effect of the other vitamins. These are the results. This was the rate of neural tube defects. Remember, these are women who've already had an affected pregnancy, so their recurrence rates was 3.5%, 21 out of 602 pregnancies. In the folic acid groups, it was 1%. That is a relative risk of 0.29 and is statistically highly significant. It reflects an estimated 71 prevention effect. Now, this analysis is done on an intention to treat in order to ensure that one's comparing like with like, that there's no selection bias. So the analysis is according to the allocation of women to the treatment groups, regardless of whether they took the treatment or whether they were already pregnant. Having shown on this primary intention to treat analysis that there's a clear effect, in order to determine the full pharmacological effect, one can then proceed to an on-treatment analysis. In other words, this analysis is restricted to women known not to be pregnant at randomization, weren't pregnant, and who had taken their capsules. And here you see the relative risk is somewhat more extreme, it's 0.17, so there's an estimated preventive effect of 83%. So in approximate terms, you can say that taking 4 milligrams of folic acid immediately before pregnancy and for the next 3 months, probably not necessary to take it for the full 3 months, will reduce the risk of neural tube defects by 80%. Now that's a massive effect. As far as the analysis on the other vitamins, you can see here that the recurrence rates were similar, 2.5 and 2%, relative risk of 0.8, but it's not significant. So there's no real reason to believe that any of the other vitamins exert a preventive effect. Now, there had in fact been a previous randomized trial performed by Lawrence and his colleagues in South Wales and published in '81. But the numbers were too small to be conclusive. They had only 6 neural tube defects. And it's this study here. And this shows the relative risk estimate was actually 0.42, but could easily have been a fluke. This shows you the results of the MRC Vitamin Study that I've just referred to. And then shortly after that, this paper from Hungary by Seisel and Dudas showed a striking effect because it was basically 6 versus 0, but again, small numbers. But perhaps a sensible summary estimate comes from looking at all 3 randomized trials, and there they are. That's the combined effect, with a relative risk of 0.19, and that is a risk reduction of 81%. And clearly the results are dominated by the MRC Vitamin Study. Now I've gone straight to, if you like, the definitive study. Let's go back in time to the first clue. Why even think of folic acid as a cause, or folic acid deficiency as a cause of neural tube defects? And also the notion that people in affluent countries actually have a vitamin deficiency in the latter half of the 20th century seems extraordinary. Well, it started with the Figlu test. Now, I would suspect that most of you are too young to have even heard of what a Figlu test. And just to give you a quick snapshot of it, is you give a loading dose of histidine that's converted into 4-amino group, which combines with THF. I hate acronyms, so I'm going to tell you the THF is tetrahydrofolate, and that forms 4-amino tetrahydrofolate. That's if everything is fine. But if tetrahydrofolate is deficient, one gets Figlu, and it accumulates and is excreted in the urine. And if you have more than 17 milligrams in 8 hours, that's a positive test. Now, it is a very non-specific test. It doesn't just test the amount of tetrahydrofolate. And it's not, I believe it's not a test that's used anymore. Now, these are the results from Hibbard and Smithers in 1965. They did a case control study. Cases were women who delivered babies with serious congenital malformations. Controls are women who delivered babies without such malformations. And these show the results limited to CNS defects. So that, oops, I didn't mean to go, let me go back. That's it. This shows that you had 69% had a positive Figlu test compared to 17% who didn't have CNS. Relative risk of 11. It's quite a striking result. You may ask, well, why didn't that immediately lead to further work? Well, actually, often in life and in medical research, the further work happens 10 or 20 years later. It doesn't always happen immediately. But perhaps it was because of these results. If you looked at the women with any defect and no defect, you had a similar result, a relative risk of 10. So it's very non-specific. However, it's pretty interesting that this, if you like, metabolic test of folate metabolism was so high in these defects. This prompted Professor Smithers to perform a multi-center, non-randomized study 10 years later. And in this study, women who had a neural tube defect pregnancy and were given a multivitamin supplement prior to pregnancy were the study subjects. The reference group, and they weren't proper controls, were women who had a neural tube defect, but just presented in pregnancy at the centers that form part of this multi-center study. The multivitamin supplement use was one called Pregnavite 40F, and that's what it consisted of. This is it here. Now you can see that's why we chose the other vitamins. The folic acid B4 is a bit of a joke. It doesn't have a formal number, folic acid, but it seems a convenience since it doesn't actually have a number. Some people call it B9, but it's not formalized. But if we call it B4, perhaps people remember to take it before pregnancy. Their dose, the dose used here was 0.36 milligrams a day. The reason we used 4 milligrams in the MRC Vitamin Study was because Lawrence used 4 milligrams, and we wanted to be sure that if the result of the study was negative, people couldn't say it's because we didn't use a high enough dose. These are his results. Unsupplemented women, 4.6% recurrence rate, supplemented 0.7%, a relative risk of 0.14, really extreme. So it's a clear result, unlikely to be due to chance. But there's a big but. Uncertainty remained And the uncertainty consisted of two elements. First of all, there could have been selection bias, and indeed there was evidence that there was selection bias. The women who'd seen pediatricians and obstetricians prior to pregnancy, a bit hard to see an obstetrician before pregnancy, but some got to see some of the colleagues, must have been alerted to this risk. So they were better educated, higher social class, and so on. So they may have anyway had a lower risk of having a neural tube defect pregnancy than women in general. The others, if there was a positive result, how did one know it was folic acid? It could have been one of the other vitamins in it. So 10 years later again, we get to 1991, the MRC Vitamin Study, and I showed you those results. So the position in 1991 is an adequate folate intake immediately prior to pregnancy prevents about 80% of neural tube defect. So that's the benchmark. But there's another but. Two important questions remained unanswered. Question one, what is the dose-response relationship between the change in folic acid intake and change in neural tube defect risk? In other words, what's the dose-response relationship? How much folate should people take, or should women take prior to pregnancy? Now, interestingly, this shows you how posing the right research question is critical in research. In fact, I would say it's more difficult than getting the answer. Is there an intake that will prevent nearly all neural tube defects? And if so, what is it? It's allied to question one. The problem is it's difficult to specify a simple dose-response relationship between folic acid intake and neural tube defect risk. For example, in California, giving extra folic acid had very little effect on the risk of neural tube defects. A case control study showed that. In other parts of the world, the same amount of folic acid had a big effect. How do you explain that? It can be answered by having a two-stage model. And it's actually a very simple. As soon as you split it into two separate questions, it becomes relatively easy to solve. The first element is to look at folic acid going to blood folate and then affecting the neural tube defect risk. So we can call this step one and this step two. Let's consider step one. Work that we did, in fact this work was work that I did with my son David, and the result is approximately an extra 0.1 milligram of folic acid intake increases serum folate by about 1 nanogram per ml in the age group 20 to 35. So we've now got the approximate dose-response relationship between folic acid intake and blood level, serum level. Let's now look at step two. The information here was already available. At the time, not in 1991, but a bit later when we focused on trying to answer it. And it came from this study from Dublin, from Ireland. And they plotted this rather interesting curve with neural tube defect risk here and red cell folate there. In this population of women, and there's this curve, and you can see the authors thought there was a threshold. So do you think there's a threshold there? Do you think this is the right way to plot the results? Because it certainly looks like there's a threshold. One thing in epidemiology is when you have a risk of disease, it's a mistake. Oops, I didn't mean to go back again. There we are. To use an arithmetic scale, because an arithmetic scale ends at naught and even goes minus. what one needs is a proportional log scale for risk of disease. And sometimes you also need a proportional or log scale on the horizontal axis. These are exactly the same data plotted on a doubling scale here, 0.5, 1, 2, 4, 8 at equal intervals, 100, 200, 400, 800 equal intervals. Now, a doubling scale is actually a log scale, but it's much easier to think of it as a doubling scale because you don't frighten people. If you say this is logs, people leave for the exit. And doesn't that fit a straight line beautifully? Is there any hint of a threshold? No. And what this shows is the higher, gosh, I'm not handling this very well. There we are. It's that as you increase the red cell folate, the risk of neural tube defects comes down. And if we now look at serum or plasma folate, you get a similar pattern. Same data, they published it. Now, the relationship between NTD risk, once you've got a proportional scale on both axes, the summary of the effect is really rather elegant and simple. The NTD risk is then equal to the new serum folate over the old serum folate raised to the power of the slope. Now, the slope is negative because it came down, so it's minus 0.81. Well, that looks a little bit frightening, but it effectively means that a 10% increase in serum folate reduces NTD risk by 80%. Let's simplify this, just to get an approximate understanding of what's going on. Minus 0.81 is pretty close to minus 1. Minus 1 is a reciprocal. NTD risk is approximately equal to old serum folate over new serum folate. It's as simple as that. Assuming this approximation that I've made, it means if you double serum folate, you halve risk. What will you do if you increase serum folate 4 times? Quarter of the risk. What if we increase it 8-fold? 1/8 of the risk. It's as simple as that. So we can now summarize these 2 dose-response relationships. The step 1, if you like, is dietary folic acid and serum folate. Dietary folic acid is not strictly correct because unless you take supplements, there's not much folic acid in the natural diet. In fact, there's almost none. It's folate. But I don't think that matters. But in terms of folic acid, it's an additive relationship. An extra 0.1 milligram of folic acid adds about an extra 1 nanogram per ml to a person's serum folate. It's like pouring folic acid into a bath. Add a bit more, it's an additive relationship. Serum folate and neural tube defects, this is a proportional relationship. Approximately a doubling in serum folate equates to a halving in risk. So we need to, in order to estimate a population effect, one has to know the starting level of serum folate as well as the amount of folic acid someone's taking. Let's illustrate the calculation. A person starts with a serum folate of 5 nanograms per ml, takes 0.5 milligrams of folic acid. The 0.5 is going to add 5 nanograms. So the 5 nanograms to the 5 they started with, it increases the serum folate to 10 nanograms. This approximately doubles the serum folate level and therefore will halve the risk. This is a more precise estimate of the preventable effect, and you can see that 0.2 would reduce the risk by 23%, go to 0.8 by about 52%, 4 by 82%. Let's see whether we can predict the results of the MRC Vitamin Study. The predicted reduction, if I go back, I'm going to show you, is 82%. The actual reduction on the on-treatment analysis was 83%. It is quite striking how close predicted results and observed results tallied. So the conclusions as far as the dose-response relationship is that continuous proportional reduction in NTD risk with increasing folic acid intake is an important conclusion. The minimum fully effective dose is about 5 milligrams a day, and this will reduce NTD risk by 85% if background serum folate is 5 nanograms per ml. It would be 36% with 0.4 milligrams a day. Now let's look at the folate intake in the population, and this is the population of England. And it shows that the median here, whoops, again, sorry about that. Here, the median in women was about 0.2 milligrams a day intake, or 0.3 for men. But notice this, that the 2.5th centile, way down in the distribution, was only half the median, and the 97.5th is double the median. So the range of folate intake is actually quite narrow in the population, and similarly for men. So if we were to increase this is the distribution of folate in the population, and this shows you the folate intake here, and this is in folate. Folic acid is more bioavailable than natural folate by approximately 2 to 1. And since we're going to be talking about adding folic acid, I'd like to convert this scale into folic acid equivalents. And that simply means, you'll see this, just halving it. So same picture, I've just changed the scale into folic acid equivalent. If we now gave everyone in the population 0.4 milligrams of folate, we'd shift them way out of the ordinary distribution. So it would be a big effect. Now, most studies show little or no significant difference in mean blood folate levels in women who had an NTD pregnancy compared to women who had unaffected pregnancies. Now, why is that? I've shown you conclusive evidence that folic acid reduces the risk of neural tube defects. How come in most studies, when you measure blood levels in pregnancies with neural tube defects, compare them without, there's very little difference? Let me just show you an example of these. I'm going back, whoops. This is affected pregnancies, unaffected, and these are the mean serum folate levels. So you can see that in the affected ones, they were lower. So this is kind of consistent with it, but let's go to another study. Almost no difference there. Another study, no difference. That study actually goes the wrong way. That study, no difference. Mills from America. And this is blood taken after pregnancy, but in women who've had them. Emory, no difference. That a bit higher. Unremarkable. How do you explain it? I could say, if you were kind of students back in London, I'd ask some of you if you could see whether you could explain it. But I think now I'll probably do the explaining myself. There's another study. It's not Wald, it's Wald. The explanation is what I call a narrow window of exposure. Let me explain it. We have here an empty graph of relative risk of neural tube defect on a slight doubling scale, or log scale, going up in sort of 0.1 to 1 is the same distance as 1 to 10 is 100. And I've actually done this on an arithmetic scale for simplicity, the serum folate. Let's now imagine that we had this group of women, and they're at high genetic risk, for example, because they've previously had a pregnancy with a neural tube defect, and that will necessarily select a group with a higher genetic background risk. And that might be the dose-response relationship between serum folate and risk of neural tube defect. The higher the folate, lower the risk. And this could be a group with low genetic risk, women in the general population. Still showing this pattern, but there's a shift. Now let's imagine that everyone in the population has exactly the same serum folate. It's hypothetical. And let's imagine it's that serum folate, 3.5. Would there be a difference in serum folate between this high-risk group and the low? It'll be exactly the same by definition. That's what it would be. But in fact, there is some variability. I showed you in the population on folate. So let's have a narrow window. And then there'll be a small movement in that direction. And that shows you there the combined effect of the genetic difference, the high risk and the low, and a small effect on the risk here in relation to serum folate. Shows the interaction. Now, what does folic acid do when you give it to women before pregnancy? It makes the narrow window a wide window. And it means that the effect goes down in the high-risk group, say by 75%, and in the low-risk group, it'll go down by 75%. The problem is that within the population, the range of exposure to folate is too narrow. An analogy may help. If everyone smoked 20 cigarettes a day throughout their lives, would we ever know that smoking caused lung cancer? We wouldn't, because we're all smoking 20 a day. It's only because some people do smoke and some people don't, and people who smoke different amounts, that we've got the variation that enables us to see the causal or the association between smoking and lung cancer. So to obtain the full preventive effect of folate, intakes of this vitamin need to be increased well beyond what is typical. And this is achievable with 5 milligrams of folic acid a day. Now, at present, women are advised to take 0.4 milligrams of folic acid unless they've already had a baby or a pregnancy with a neural tube defect, in which case they're advised to take 5. It's irrational. All women should be advised prior to pregnancy to take the higher dose to get the full preventive effect. Now, unfortunately, in countries such as America and Britain, you can't get folic acid without a prescription above 0.4. That's why people latch onto 0.4. But in some countries, such as New Zealand, you can get 5 milligrams over the counter without a prescription. So we need to, in America and certain countries, make folic acid available at 5 milligram dose without a prescription. Now let's look at the costs of folic acid fortification of flour. The cost of folic acid itself is about 15, if you add the appropriate amounts, it's about 15 cents per metric ton of flour. The total cash folic acid, labor, etc. would be about 30 cents per metric ton. This is enough flour to feed a person for 30 years. About 1 cent per person per year, or about $1,000 per neural tube defect prevented. The cost of adding folic acid to flour is minimal, especially when compared to the cost of treating children with spina bifida and the immeasurable impact on their families. The cost of folic acid fortification has been studied in various countries, and I give just 2 examples. In Chile, if you like, the cost effectiveness, it's 12 times more expensive not to fortify and to care for the children than fortification. And in America, the differential is 4 times higher, 1 to 48. In 2000, the British government concluded that on scientific, medical, and public health grounds, universal folic acid fortification of flour at 240 micrograms per 100 grams in food products as consumed would have a significant effect in preventing NTD-affected conceptions and births without resulting in unacceptably high intakes in any group in the population. let's look at the effect of fortification in America. The minimum level of fortification specified in the US was 0.14 milligrams. In fact, it was about 0.28 because there was an overage. And the extra folic acid delivered to the population was about 0.2. Now, do you remember the prediction? What would we predict? 23%. Where do we get that from? Here. What was observed in the United States? 19%, with confidence intervals that include it. So it predicts that. In Chile, which is perhaps the best example of a country that have introduced fortification, it started in 2000. The fortification level was 220 micrograms per 100 grams. That led to an increase on average of 0.4 milligrams a day, and that approximately doubled red cell folate level in the population, and the predicted reduction was about 50%, if you remember from what I've said, and in fact 43% was observed with confidence intervals from 29 to 55. Mandatory fortification of folic acid has been conducted in 71 countries throughout the world, and here they are. The first major country to do it was actually the United States, but it was actually one of the Gulf states that I think actually got there first. I think it was Oman. These are the countries that are fortified. It looks like credits at the end of a movie. Now, in addition, 5 countries have voluntary fortification, with most flour fortified. Burkina Faso, Cape Verde, so-called Democratic Republic of Congo, but not so democratic, Qatar, and United Arab Emirates. No European Union country has fortified. What are the benefits of fortification? Neural tube defect prevention, possible prevention of cardiovascular disease, particular strokes, but uncertain. There's some of the evidence. And the prevention possibly of other birth defects such as facial clefts. What are the hazards? Masking and progression of B12 neuropathy, impaired control of epilepsy, miscarriage, colon cancer, breast cancer, and twins, if you call that a hazard. All are speculation without evidence, and indeed there is evidence to show that this is not true. Fairfield and Fletcher said we are unaware of reports of folate toxicity. The effect of diet in increasing folic acid is, you'll see here, that you have to eat an awful lot of Brussels sprouts, spinach, green beans to get 0.4 milligrams of folic acid a day. It's not practical. Dietary change is not a practical way of achieving this. The use of folic acid supplements. How often are they used? In our own program at the Wolfson Institute, we asked the question, did you take a daily supplement containing folic acid? If so, when did you take it? This is in our screening program for neural tube defects and Down syndrome. These are the results on nearly 500,000 women. 30% took it prior to pregnancy. That's all. 56 took it after they knew they were pregnant, and 40 not at all. And this is the pattern over time. If anything, it's got worse. And this shows you taking after pregnancy was concerned. It seems odd. What seems odd? Putting folic acid in the contraceptive pill. Why? Put it in something that's designed to prevent you becoming pregnant. Because your blood levels stay high 3 months later. And what happens when you stop taking the contraceptive pill? Quite likely to get pregnant, so you'll be covered. And that's now happened. The balance of safety. Is there anything that is added to food for which there is such clear evidence of benefit and such clear evidence of safety as folic acid? I think probably not. Then why is there such a reluctance in some countries to fortify flour with folic acid? And I'll be quite quick here to close. Opposition to the nanny state. Some decisions need to be taken collectively, and governments have to take this responsibility. In fact, if one uses this silly nanny state argument, then forget about public health, because public health is about making collective decisions that improve the quality and health of our lives. The view that speculation of harm is evidence of harm. This is a misconception. It's necessary to distinguish speculation from evidence, which we fail to do. We don't do that very well. Overcautious regulatory authorities, they mainly ask, what are the risks of folic acid fortification? Instead of asking the simple question, what are the risks of not fortifying? Why should everyone consume extra folic acid when only a few will benefit? And that's only women. Well, how absurd. Because parents are responsible for the children and their grandparents and family and society. That is based on two false presumptions. Only a few pregnant women will benefit, which is untrue, and people act selfishly when there's no cost to themselves. They don't. They act altruistically in those situations. And media hyperbole, the possibility of harm, attracts the attention of the media. Now, I wrote in 2004 that, contrary to current perception, the key to effective public health is not individual choice, but collective choice. Charges of paternalism and pejorative labels such as nanny state, with the false innuendo that we are being controlled against our wishes, are unhelpful, because effective public health needs to be integrated into the infrastructure of society. The Food Standards Agency approved this, but the British government is still ignoring it. And even the Times, with an article, The Bread of Life, have said objectors to fortification, and you can read that for yourself, saying that just have information and advertising campaigns, and they say such an argument that advertising alone will do it is wholly spurious. Cholera would never have been conquered if clean water had been optional. There could be no more welcome example of public health policy in action. And that's a relatively conservative newspaper. Mandatory fortification is simple, safe, and ensures population coverage, but it will only have a partial effect if you use 0.4 milligrams, so a daily folic acid supplement of 5 milligrams starting before pregnancy is needed as well. I say that because I think it would be too extreme to fortify flour at much higher levels because of uncertainty. WHO has approved fortification. This is a result of a European WHO meeting in 2002. People have said, and this is Walter Willett from the States, the failure of most countries to fortify food with folic acid represents a major lost opportunity. They're being very kind. I would put it to you that failure to fortify flour with folic acid is like having a polio vaccine and not using it. Now let's look at the global question, and I'll just end on that. Preventable by fortification globally is 120,000 cases of anencephaly and spina bifida a year. The extra preventable amount with the 5 milligram fortification is another 120,000. That's nearly 250,000 a year. The total preventable since 1990, the publication of the 1991 paper, is 5 million. There's the 5 million. That's a big circle. How many have been prevented? Watch that circle. These are the ones not prevented. How many cases of phocomelia from thalidomide occurred in total throughout the world? 10,000. When this came up, there were horrendous rules, regulations that affected the licensing of drugs. Banning a harmful substance should not trump adding a beneficial one, but it does. Both are important. It's not one or the other. So my conclusions. Chairman, is neural tube defects are a folate deficiency disorder. We should not be complacent because we might be rich or well-fed. This is an indigenous micronutrient deficiency that affects all populations. The dose-response relationships are specified. 5 milligrams a day should be the amount that everyone takes, all women take prior to pregnancy, not the lower amount. By all women who might become pregnant, not who are planning a pregnancy, but who might become pregnant. And all countries, including European ones, should fortify flour with folic acid at a level of 240 micrograms per 100 grams of flour as a minimum. I think on these summary points, I'll end and thank you all.